And if you guys are watching this after the fact, like usual, I will be commenting on the timestamp when I actually start. And as per usual, we're going to go ahead and wait a few minutes before starting. And I'm going to go ahead and grab that link now for those that are in the Discord. Now for those that are in the Discord. All right. Hello. Hi everybody. Let me know in the Discord if you can see me. Hello. Yeah, so I'm going to wait a few minutes, just wait for people to get logged in. I don't want to get rushed right into the lecture right away. I'm expecting to only go for maybe 30, 40 minutes today. We'll see. I'm also waiting for my wife to finish feeding the boy. I think they're about done. All right. Somebody's typing. Okay, that works. All right. Yeah, hopefully everybody's hanging out okay with this whole Corona thing. Hanging in there, staying at home. Hopefully you're able to feed yourself. I know these grocery stores are crazy right now. All right, before we get started, does anybody have any questions? Well, first things first, the plan they had for today was molarity, dilutions, some pH calculations. Someone had a request for like which side Equilibria dominates, those kind of questions. So I'm just going to wait a second to see if there's any questions, and then I will get started. Right, so let's go ahead and switch some gears here. I'm going to show you guys what I did. So basically what I did was I just Googled some worksheets just so we have something different to work with. So let me actually just switch over to the browser view here. Oh, wrong. This one. All right, so basically what I did was I literally Googled what's showing on the top here. So I Googled molarity practice problems, and then I Googled dilution practice problems, and then pH practice problems. You also want to make sure that you probably want to add with answers in your search. That way you'll get answers as well. Typically what you'll end up finding are different worksheets that people have posted online, you know, other colleges. I'm actually going to give shout outs to the other colleges here that we use their papers from. But yeah, typically you'll just get other colleges' work, you know, some other professor, whatever, worksheets, and then go from there. All right, so I'm going to go ahead and take a look at that first problem there. Move my keyboard. All right, so how many grams of potassium carbonate are needed to make 200 milliliters of 2.5 m solution? So I'm going to write down the information we need, and then I'll switch the view. So potassium is K+, carbonate is CO3, CO3 2-, and we're trying to make 200 ml. We need to know how many grams, and then we're making 2.5 molar solution. All right, so switch over to presenter camera. Oh, hey, by the way, I actually updated the lighting here a little bit. I actually have a little LED light that's like right there, right above where I'm working. Give me a much better light, and I don't have much of a shadow, at least as much as before. So let me know if the lighting's better for this. I'm trying to improve the quality. All right, go ahead and take a look at the question here. So if this is a +1, this is a 2-. The actual formula here for potassium carbonate is K2CO3. All right, thank you for the feedback on the lighting. All right, and it's asking us how many grams do we need to make the solution. So what we need to first do is take a look at what we're given. Remember, molarity is moles per liter, and then we have milliliter. So I'm going to go ahead and set it up as a conversion problem. And when you use molarity in a conversion problem, I highly recommend that you write out mole over liter rather than just the M here. That way you'll see that things cancel properly. So, all right, so we have 2.5 mole per liter, like that. Remember that if we take molarity times the volume, you have moles because liters cancel. You just need to make sure that you write in this in liters here. Otherwise, you're going to have an extra step for conversion. So 0.200 liter. Once again, this is in place of the 0.2 liter. The last thing we need here is we actually need the molecular weight of this compound. Recall we did go over this. Essentially what you do is you take the weight of each of these and then add them all together, and you would get those weights on the periodic table. For the sake of time, like in the video, I've been going ahead and using the app that I showed you guys a couple times, this periodic table app. So I'm going to go ahead and use this real quick to get me that molecular weight. So K2CO3, done. And I'm going to go ahead and use that weight there, the 138.206, and we are going to divide by that. Oops, sorry, multiply. Because this unit is grams per mole, and we want the moles to cancel, giving us grams at the end. So 138.206 grams per 1 mole. If you're ever unsure of your setup, remember you can always go ahead and check if things are canceling properly. So liters cancels, and then our moles cancels, and then we have grams left over. That's what we want. All right. I changed the calculator I'm using. So the calculator I'm using is actually just an app because it shows it better on the stream. It's actually Hyper Scientific Calculator. It's free, but the free version has a banner. Unfortunately, I want you to upgrade to the Pro to get rid of the banner and the little ad that flashes up there, but it's fine for today. So 2.5 times 0.2 times 138.206. And there we go. There's our answer, 69.103. And I like to report my answers in the digits we were given. We had 2 digits originally. So we're going to go ahead and say our answer is 69 grams. Like so. Are there any questions on the first problem here? Any questions? No problem to the comment in Discord. I'm really glad you guys are enjoying this. This is actually a lot of hard work to figure out how to do this properly. All right. So let's go ahead and continue. I'm going to bring up the, yeah, too easy. I was say too easy of a problem. Let's do a harder one. All right, so let's switch back over to the browser. All right, so next question I want to go ahead and do is let's go into the next one here. It's a little bit more tricky. It's asking you how many liters of a 4 molar solution can be made using 100 grams of lithium bromide. We're going to need the molecular weight of lithium bromide again, but let me just write down the information we need. So LIBR for lithium bromide. We're making 4 molar, and then how many liters? All right, on this problem, we're actually going to use that 4 molar as a conversion factor. Let me just go ahead and show you. But before I start, though, I am going to go ahead and get the weight for lithium bromide. So LIBR. So I know it's just LIBR because lithium is a +1, bromine is a -1, so it's just 1 to 1. And our molecular weight we're going to need is 86.845 grams per mole. All right, so this one's a little bit different in that this is actually our given value that we're going to start with. So 100 grams. I'm going to go ahead and start off by converting to moles. So we're gonna divide by the molecular weight. So 86.845 grams per 1 mole. All right. In order to figure out how many liters we need, we're actually going to use this 4 molar as a conversion factor. So it's actually going to work out where we have 4 mole on the bottom and then 1 liter on the top. So if you think about it here, this is basically going to tell us how many liters we're going to make. And then just like before, you can go ahead and cancel things out. So grams cancels, moles cancels, we have liter left behind, we're good. All right, so switch back over to the calculator app. Let me clear. All right. So then we have 100 divide 86.845 divide 4, and looks like we're actually not going to make a whole bunch here. So it looks like we're going to make 0.287 or 289. Sorry, 288. So it looks like we can't even make a whole liter with that amount. We need more. All right, let's go ahead and take a look at some of the other problems here. All right, let me switch back over to the browser. All right, I think I want to go ahead and maybe take a look at 3 and 4, and then we'll take a look at the next worksheet. There aren't too many problems here. Let me just double check which one I want to work at. Yeah, let's just go ahead and do 3 and 4. And then we'll call it good on the molarity stuff for now. Double check Discord. All right. Okay, just like last time, I'm going to go ahead and write down the information I need, and then I'm going to go ahead and switch back over to the presenter camera. All right, so basically it's asking us what is the concentration of iron 2 chloride. So this is FeCl2, iron 2 chloride. And it's saying here that we have 200 grams of the FeCl2, and then we have volume of 450 ml. All right, this one should be pretty straightforward. We have to do a couple conversions. Remember, molarity is moles over liter. We're given grams and ml, so we basically need to convert grams to moles, and then this one milliliters to liter. So doing our setup here. So 200 grams of FeCl2. I'm going to need the molecular weight for this. Typically, whenever you're doing gram to mole stuff, you typically need the molecular weight. So FeCl2. Oh, I also do want to mention that since we kind of skipped the naming part, I would actually provide these formulas for you. I just know what the formula are from the name because, you know, I had to learn it in school. So. All right, so 126.751 grams per 1 mole. So now the top part is in moles, and then we're just going to go ahead and divide by 0.450 liter, like that. No problem. All right, so there's our setup. Remember, your calculator is always the last step. Don't break out the calculator till you fully are understanding how to solve the problem. So 200 divide 126.751, and then I'm going to divide again by 0.45, and there is our answer. And to 3 digits, let's go ahead and say 3.51 molar. All right, so let's go ahead and take a look at the next one. If you guys have any questions about these ones as we're going along, just throw it in the Discord, and then we'll see. I'll see your questions. All right, so back to this view. So next question is saying how many grams of ammonium sulfate are needed to make 0.25 molar solution. Wait.
Your mom does not ask for mine by then.
This doesn't make any sense. How many grams of ammonium sulfate are needed to make a 0.25 molar solution at a concentration of 6 molar? That question doesn't make any sense. Let's go ahead and do the next one. Next one here, what is the concentration of a solution with a volume of 2.5 liters? That's the same kind of one we just did. All right, I think number 6 is a better question out of the choices here. So I wanted to point out the reason why this question didn't make any sense is because you need a volume. Like it's not telling us the volume to make. I'm wondering if this part here should have been 0.25 liter. That the question would make sense then. I think that's a typo. That M right there. I'm pretty sure it should have been 0.25 liter. Anyway, let's go ahead and do number 6, like I said. So how many grams of copper 2 fluoride, that is CuF2, are needed to make 6.7 liters of 1.2 molar? Question essence for grams. All right, switch back over. All right, so I'm going to go ahead and put the, these are going to be on top. Remember, if we have molarity times volume, that's equal to moles, and then you just do moles to grams. I think the first one we did was kind of similar to this. So let's go ahead and, we need the formula, sorry, the molecular weight for the copper 2 fluoride. And here we go. So CuF2, all right, looks like it's 101.543. So I'm going to go ahead and first start off with 1.2 mole over liter. I'm going to use this part to figure out where to put this at. Remember, you just multiply. So then liters cancels out. And then the last part here, what do you guys think? Am I going to multiply or divide by molecular weight? So once again, the question was, do I multiply or divide by molecular weight for the final answer? Awesome, guys. Good job. Multiply. So 101.543 grams per 1 mole. All right. And then I'm going to keep saying it. Calculator is always the last step. So always last. So 1.2 times 6.7 times 101.543. And there we go. I'm getting 816. So let's go ahead and take it to 2 digits. So I'm going to go ahead and report it as 820 grams. All right. So for the molarity stuff here, this is kind of like what you can expect to be on the exam, questions like this. If you've taken the quiz already, you'll see that the quiz is kind of similar to similar calculations. But typically the part with the molarity students have a hard time with is the dilution stuff. So let's go ahead and switch over to dilution problems now. Okay, so first question there, we can go ahead and do that. Oops, let me switch over to the browser again. All right, first question. If I add 25 milliliters to 125 milliliters of a hydroxide solution, what will the molarity of the diluted solution be? So this one could be a little tricky here, and you have to recognize that the volumes are additive. So this is going to be an M1V1, M2V2 question. So the question, I just got a question in Discord. The question was asking about rounding and exact numbers. Typically, I allow a range for numbers. So if you don't get the exact number as me, as long as you're pretty close, then it'll mark it as correct. For any questions like that, yeah, for any kind of fill in the blanks for numbers, I will give it a range. All right. So once again here, so we have 15 molar solution of NaOH. We're starting with 125 mils, and then we added 25 mils. All right, that's all the information I need. I'm gonna go ahead and switch over. Okay. So on this particular question, the identity of what you have in solution, what your solute is not relevant to answer the question. So you don't need the molecular weight for this one. So remember the equation we use is M1V1 equal to M2V2. You can put any concentration here for M, and if you're following the book has it as C1V1 equals C2V2. Doesn't matter. Just whatever concentration in there, whatever volumes in there, it all works out. As long as you match on both sides. All right, so it looks like we need to solve for M2. That's the one we're solving for. Because I like to say this is our starting point, this is our ending point. So solving for M2. So it looks like we're going to have what, V1 over V2 times M1. Remember last time I mentioned this right here, that's a dilution factor. This part right here, that's your dilution factor. All right, so our starting amount is 125 ml, and then 150 ml, and then we go ahead and say our 0.15 molar. All right, so there is our setup. So 125 times 0.15 divide 150, and I'm getting 0.125 for this. Or 1/3 to 2 digits there. So it didn't change very much because we only added a little bit of water to it, so it shouldn't have changed a large amount. Typically, if you're going like liters at a time, you have a huge change in the volume there, so not a big change here. The tricky part here, I think, is to recognize the volumes are additive. Let me add that here. Volumes are additive. And I do want to point out that if this question was in a test bank, very likely there would have been a choice where it was 125 divided by 25. Because that's probably a common student mistake, and that would be one of the choices in a multiple choice and be a wrong answer. So be aware that the author of the book knows that what common student mistakes are and will build them into the choices. So be aware of that. All right, let me go ahead and switch back over. Let's go ahead and take a look at the next one. All right. So the next one here says, if I add water to a 100 milliliter solution until the final volume is 150, what will the molarity of the dilute? That's actually the same kind of problem again, almost exactly. Let's do a different one. We can do this one, number 3. Yeah, let's go ahead and do number 3 and number 4. These ones look different. So number 3, how many? So let's go ahead and write this down. So 0.05 molar. And then we're going to say 250 mils of 10 molar. And it's asking us how much. The question is probably for volume. All right, so I think we have enough information now. All right, so just like before, we have M1 V1 equals to M2 V2. And it looks like we're making this from this. So I'm going to go ahead and say that we are solving for V2. It's asking us how much of this can we make. So V2 is going to be M1 over M2 times V1. All right, so starting off with, we had 10 molar. We're diluting it to 0.05 molar. And our starting volume, we can go ahead and leave it in milliliter here. So let me just go, and if I leave it in milliliter, my answer will be a milliliter. So let's go ahead and do that. So break out the calculator now. So go ahead and take 10, divide 0.05, and then times 250. And it looks like we're getting a lot here. That is pretty concentrated, so that makes numerical sense to me. So it looks like 50,000 milliliter, that's 50 liters. So we can report our answer as 5.0 times 10 to the 4 ml, and this is 50 liters. So we can make quite a lot here. All right. Next question. So it says here, I have 345 milliliters of a 1.5 molar NaCl solution. We're boiling some water away, and then what will the molarity of the solution be? So I'm going to go ahead and write down the information we need, and then switch over. So 345 mLs. The concentration is 1.5 molar NaCl. Just like the last one, the NaCl is not relevant to answering the question, so we don't need molecular weight. And then I'm going to say evaporate to 250 ml, and then we can answer this question. All right, so if you think about it here, if you are actually removing some of the water, your solute stays there, so the concentration goes up because you're taking away some of the solvent, and none of the solute goes anywhere. So I'm going to go ahead and say that these are the ones, this is our 2, and we're solving for M2. So M1, V1, M2, V2, we want to know what the new molarity is going to be after the evaporation. So it looks like we're going to have a V1 over V2 times M1. All right, so V1 is going to be 250 ml. Remember, units have to match, so they're both milliliter, we're good. 345 milliliter, and then multiply that by your 1.5 molar, like that. All right, so 250 times the 0.5 divide 345, and there we go. New concentration to 2 digits is going to be 1.1 molar. Wait. Hang on. Did I make a mistake here? Hang on, let me double check. I made a mistake here. What is it? What do you guys think? What is my mistake? I made a mistake. This is the wrong answer. Did anybody see the mistake? It's a very easy mistake to make. Yep, these numbers here are supposed to be flipped. So, oops. Happens to the best of us too. So let me go ahead and fix it, and then I'll recalculate. Yeah, because I was just saying the number should have went up, because it makes physical sense for the number to go up if you're taking the solvent away. Yep, so oops. So our 1 is 345, and then 250 ml. Yeah, as soon as I saw that number being smaller, I knew that was a mistake. So 345 times 1.5 divide 250, and the answer is going to be 2.1. Now that makes more sense to me because the volume, the concentration should have went up. Yep, so 2.1 molar. So, oopsie. Make mistakes sometimes. I'm only human. Contrary to popular belief. All right, so how much water would I need to add to... Are we in the wrong group chat? Oops. Hang on. Yeah, you need to talk into the Chem 108 chat, otherwise I won't see it, guys. Someone was talking into the general chat. I don't have that window open. All right. So this is pretty much what you can expect for the dilution problems. Remember, we did the Boyle's law stuff back in the gas law chapter. The math is the same. So make sure that you do the same kind of setup or kind of math you were doing for the Boyle's law stuff. All right, I want to go ahead and switch over to looking at some pH problems. Let me go ahead and switch over to the browser. Okay, I wanted to work through a couple of these guys. I wanted to work through, let's go ahead and do 1 and 2 are kind of the same problem. Notice even the numbers are the same. We can do this together. And then I want to do 3 and 4 as well. 4 it takes a little bit of critical thinking, so I definitely want to work on number 4. All right, so question now is, what is the pH of 0.0235 molar HCl? And it's also asking us what is POH, so we can do that together. All right. So, remember for pH we had two different things. So for pH, this was negative log of the concentration of H plus. It's in molarity. And then if you're going the other way, if you have this H plus, this is simply 10 to the negative pH. These are inverses of each other. I know we didn't go over a lot of detailed logarithms, but these are opposite operations. You could think of it as like multiplying and dividing, how they're opposite. These are opposites. All right, one thing we have to recognize here is that is actually telling us that H plus, this is going to deliver 1 mole. So we're going to go ahead and have the same amount. I do want to mention in problems like this, you're only going to have strong acids to work with, because I believe I mentioned last time that if it's a weak acid, you end up with an algebraic equation. This is no longer true for a weak acid. So this has to be one of the strong acids for a question like this. All right, so in order to get the pH, we just do the negative log of that. So pH is negative log of 0.0235. Remember, pH is unitless, so no units on pH. And then we don't go over 6 too much in this class, but typically we take a log of a number, you gain a digit. So let's go ahead and say log of 0.0235, and then remember it's going to give you a negative number, but we take the negative of that here. So I'm going to write positive 1.6, and I'm going to gain a digit here, so 1.629, like that. All right, so there's your pH. To get pOH, remember we did this equation. pH plus pOH is equal to 14. And then solving for pOH, we end up with 14 minus pH. So 14 minus this number. So typically what I'll do is I already have that in my number, the negative. So I can just say plus 14. Oh, hang on. Right, plus 14, and there's my answer. So 12.371. Right, are there any questions about this one? Any questions? Move that out of the way. All right. Nope. Okay, let's go. I'm gonna go till I run out of paper. I got like 2 big reams of paper. I'm not running out anytime soon. I'm kidding. All right, so the next question here, let me switch back over to the browser view again. So I want to do number 3 and 4 as well. So this question is saying, what is the pOH of a 6.5 times 10 to the minus 3 molar potassium hydroxide solution? So just like the last problem here, we're going to get 1 mole of hydroxide per 1 mole of the KOH. So I'm just going to go ahead and write down the OH minus concentration is equal to 6.50 times 10 to the minus 3 molar. And I need to figure out what pH is. I'm going to show you guys 2 ways to do this. There are 2 ways to do these. Oftentimes for pH problems, there are 2 approaches you can take. Use whichever one works for you. All right, so if I take the negative log of this number, that's not going to be pH, that's going to be pOH. So remember that pOH is equal to the negative log of the hydroxide concentration. So that's going to be negative log of 6.50 times 10 to the minus 3. So calculator time. So remember, I like just doing the log here just to make it a little bit shorter. But 6.5 times 10 and to the minus 3. And there we go. I'm getting a 2.187 for that. All right, and then just like before, we know that pH is equal to POH. Oops. It's 14 minus POH. 14 minus POH. So I'm just going to go ahead and say plus 14 on my calculator. And there we go. There's our answer, 11.812. Or 813. 11.813. This answer makes sense to me because we do have a fairly high hydroxide solution. It should be alkaline or basic. So that's a basic pH. The other approach I want to show you guys is we are given the hydroxide concentration. Remember, we have the expression for Kw. Kw is equal to H plus times OH minus, and this is equal to 1 times 10 to the minus 14 at 25 degrees C. So then what I can do here is just solve for H plus and take the negative log of that number. So I just want to go ahead and write it out. So H plus is equal to, looks like we're going to have Kw over hydroxide. So when I plug in for Kw, I need to plug in that number. So 10 to the minus 14. And then I'm going to say divide by this number. When you're doing divisions like this, you definitely want to be careful of your parentheses. This is negative 3. Oops. There we go. All right, so there we go. I'm getting 1.5 times, so 1.538 times 10 to the minus 12. That would be molar. And then pH is negative log of H plus. So I'm just going to take the negative log of that number. So log of 1.538 times 10 to the negative 12. And look, I get the same answer, 11.813. Okay, let me check what's going on in the Discord. Nothing. Okay. All right. So any questions about this one? I'm thinking this way is probably easier, but I just want to show you guys that some people like this way better. I think this way is easier. So whatever works for you, they both get the same numbers. All right, so let's take a look at another one. So this next one here does require a little bit of critical thinking, and I'm actually going to write out a reaction for you guys to help out. So it says here that a solution is created by measuring. So I'm going to go ahead and write these out here on the paper. So we have HCl plus NaOH, and these are going to undergo an acid-base reaction. And let me write down what we have here. So it says we have, what, 3.6 times 10 to the minus 3 mole. And then we have 5.95 times 10 to the minus 4 mole. All right, and then our total volume is going to be 1 liter. What is the pH of the solution? All right, switch over to the presenter camera. We can see what I have. All right. So the thing that's going to happen here is the acid base are going to react with each other, and you're basically going to have one of them is going to be left over. So basically the one that is going to be left over is the one that you have more of. And look at these numbers here. This one is in higher quantity. 10 to the minus 3 is larger than 10 to the minus 4. So I'm going to go ahead and write out what I'm saying here. So we have, if we have excess NaOH, what I'm saying here is we have the starting NaOH, and I'm going to specify here this is the larger quantity. minus the 5.95 times 10 to the minus 4. Oops. Let me correct that. That's reacted HCl. It's going to be the 5.95. This is a smaller quantity. So if the question gave you more acid, it would just be excess acid instead, then you would just flip these guys. But typically you have whatever one's larger first minus a smaller one. This only really works out to be 100% true if the acids are 1-to-1 molar in the reaction. So just for extra practice here, the products are going to be water and NaCl. So, all right. So I'm going to go ahead and start off by first taking our 3.6. Let me clear this out. So 3.6 times 10 to the negative 3, and then minus the 5.95 times 10 to the negative 4. All right, so let me write this number down here. So this is the hydroxide concentration after the acid-base reaction. So 0.003005. I don't want to round yet. This is molar. So then to get the pOH, negative log of that number. All right, so log, oops, keep doing that. Log of the 0.003005. And there's what I get for that. This is going to be a positive 2.522. And then just like the last problem here, after you have that number, we can go ahead and say that pH is equal to 14 minus 2.522. So plus 14, and then final answer is going to be 11.477. Oh, 478 actually for rounding. 478. All right. Are there any questions on these ones? Take the next problems. Next one's too easy. All right, so I do just want to make it clear that you guys understand that we are not doing any calculation problems with weak acids or weak bases. So these are all going to be strong. So yeah, we go over this in Chemistry 122. It ends up being some pretty nasty algebra, ice tables that they're called. We are not doing that with you guys here. So just because you guys don't have the algebra background as a prerequisite for the course. If there was an algebra prerequisite, we would for sure be going through it. So, because it is pretty important, but we don't have it here.
Got much too.
All right, I did want to take a look at another last problem. So there was a request that I take a look at acid-base equilibria questions, like which side dominates. In order to do that, I'm actually going to look up a pKa table, and I'm going to go ahead and do it live on the stream, show you guys how I do this kind of stuff. So browser, and let me open up a new window, and then I'm going to use Google. All right, so pKa table, and then let's do acids. See what we find. All right, let's go to images. So I think this one here could be a good one. Hang on, I want to do some organic acids. Let's do organic acids. All right, so I like this chart right here. Let's go ahead and use this one. Hopefully you guys can see it okay. Yeah, so this table on the right here, I'm gonna go ahead and use it. So let's go ahead and take a look at an acid-base reaction. So let's go ahead and say that we have phenol, that's a benzene with an OH on it, reacting with hydroxide. So I was saying in the last problem there that typically for calculations we're going to be typically working with strong acids and bases. For these kind of problems it makes more sense to use weak because typically the reaction ends up being like kind of equal a little bit, one side dominates, you know. But typically if you have a strong acid or strong base somewhere in this problem, it's really obvious which way it's going to go. So switch back over here. Wait, I need the pKa. So the pKa I'm seeing as 9.9. Am I reading that right? 9.9? Yeah, 9.9. Okay. All right, equilibrium. So once again here, this is phenol. We have a benzene with an OH and then reacting with a base hydroxide. So the way this is going to work, this is our acid. This is our base. And then when you're predicting products for an acid-base reaction, you have to remember what the conjugates are. So the conjugate base of an acid, basically you lost an H. The conjugate acid of a base, you gain an H. So I'm going to go ahead and draw those over here. So we're going to get phenoxide. And then sodium ion is going to go with it as well. So there is the conjugate base. And the conjugate acid of hydroxide is water. Like so. So if you're being asked to predict equilibrium, you have to identify the acid on both sides. So here we have an acid on this side, we have an acid on this side. So these values were given in the table to be 9.9. So these are pKa values I'm using here. 9.9, and then the pKa of water is 15.7. Which side dominates? So if you have forgotten how to do this here, what we do is we take a look at which side has the weaker acid. That side dominates. So which side has the weaker acid? Yep, products. Good job. Products dominate. So remember that typically what ends up happening is if you're actually comparing the bases here too, this side, everything on this side is weaker. So let me write weaker base, weaker acid. This is all relative to each other, right? And then on this side, we have a stronger acid and then stronger base. All right. Any questions about this one? Should we do more? What do you guys think? Do more? Do a couple more? Probably. Cut the stream. Up to you guys. Yeah, I'm going to go ahead and just do one more. Yeah, yes, please. All right, let's go ahead and do some more here. I'm thinking the hard part here probably is actually writing this part out. It's probably the hard part for you guys, maybe. So let me switch back over to the browser again. There we go. All right, let's go ahead and take a look at this one. So I'm writing out acetic acid. Acetic acid is like the fifth one down, it looks like. That had a pKa of 4.75. And then we are going to react this with, let's go ahead and say that it is the tert-butoxide ion. Tert-butoxide, and that had a pKa of 18. All right, let me just go ahead and bring it back here. Oop. And presenter camera. All right, so this is the one I wanted to look at. If you're being asked to, if you're being just given these guys here, Typically, your organic acids will have the carboxylic acid functional group. These are organic acids. They're either going to be that or they're going to be like an alcohol. These are also acids in organic chemistry, just not as strong as these ones are. So OHs. It works out where the pKa of alcohols are in the range of like 10 to like 15 usually. In this case, it's going to be a little bit larger. And then your carboxylic acids are typically around 4 or 5, meaning they're stronger acids usually. So in predicting products here, we can take equilibrium. Take a look at here. So here, this is going to be our acid. This is going to be our base. So I'm going to basically have this H go over here. So we get the acetate ion, acetate. K plus goes with it. And then we're going to have tert-butyl alcohol. This is going to be the acid on this side. And the pKa from the table that we just looked at was 18. Like that. And then I like to identify what's what. So we have acid, base. And then over here we have conjugate base. Let me make a little line there, separate problem. And then conjugate acid. So what do you guys think? Which side dominates? Yep, products again here, guys. Products dominate. Next question I could ask you guys here too, it would be like, what is the KEQ for this? Is the KEQ greater than 1 or is KEQ less than 1? What do you guys think? Hang on, we got a guest again. He likes to make cameos. Hi. We're doing acid-base chemistry today. Are you hiding your face? Or the light bright? Yeah, it's gonna be greater than. Someone answered the question in the comments while I'm fooling around with my son. Can you give me bunny ears? All right. Yeah, so the answer is actually going to be greater than 1. This one. So typically, we went over this in class. Remember that, let me just review here real quick. KEQ is equal to the concentration of products over reactants. So if you're saying products dominate, you're saying that this part is larger. So that means it should be greater than 1. In the reverse case, if reactants dominate, you get this one. So this is for reactants dominating. This is for products dominating. All right, I think we'll go ahead and do one more, and then I'll see if you guys have any questions, and then we'll cut the stream there. All right, so let's go ahead and this one looks a little tricky. I'm actually going over this chemistry in fine detail with my organic classes next week. They're going to love it. All right, so let's say we'll have that. Do they have hydrogen sulfide in here? They don't have hydrogen sulfide. All right, so yeah, I'll look at that one after I do this problem. Let's just do one more here. So I want to go ahead and, which one do I want to do? I can't decide which one I want to pick. I want to do something different. Do they have ammonia on here? Hang on, let me look at the pKa of ammonium. I think it's about 9. Let me just double check though. So pKa of ammonium, I'm pretty sure it's about 9. Yeah, 9.3 for ammonium. So let's go ahead and do that one. That's too close. Oh, crap. Hydrogen sulfide? pKa of hydrogen sulfide. This one's at a pKa of 7. Let's do that one. All right, so switch back over. So I want to go ahead and say, so we have that, and then we have HS minus. Predicting products here. So on this particular problem, the acidic H's are being shown to you explicitly. So we need to take one of them away. Typically, if you have something neutral, you take away one of the H's. You have just one H there now, and there's a lone pair with a negative charge. It looks like Jar Jar Binks now. You guys can't unsee that. That's totally Jar Jar, that structure. All right, and then the pKa of this one is about 7. All right, so what do you guys think? Products or reactants dominate? Do products or reactants dominate? Yep, reactants dominate. Reactants dominate. And then we end up with KEQ less than 1. All right, so let me go ahead and pull up that question, and then I'll have to grab that file, so give me a second. So the question was, can you look at question 4 on the 3.2 group activity sheet? So go here, desktop, 108, 3.2, and let me switch over to the file view. There we go. So here's hang on, what question was that again? 3? 4. All right, so question number 4. All right. So the question here is, let me actually blow this up. Let's make it full screen. And then zoom in. All right, so question number 4, the equilibrium constant values for the reaction are listed below. Indicate whether the products or reactants are favored. So this is an issue of the KQ being greater than 1 or less than 1. So this value here, basically is if the exponents on this number are positive or negative. What do you guys think? Is this greater than 1 or less than 1? This 10 to the 12. So, yep, it's greater. Actually, just for extra practice here, I'm going to go ahead and write out the equilibrium expression for this one as well. So let me switch over to the presenter camera. Yep, it's greater than 1. So that question, didn't I have a file multi going on here? File multi? Where is it? There we go. File multi. Let me zoom in. Oops, that doesn't help. Let me hang on, fumbling a little bit here. I want this on top. There we go. All right, so that question there, I just want to go make sure that we're all getting our practice here. So KEQ for that first one is product over reactants. So we have NO2, and then notice on the equation there, there's a 2 on the NO2, so that gets put up here, like that. And then we're going to have NO on the bottom, squared, and then O2. That question is telling you that it's greater than 1, so that's telling you that products dominate. Products dominate. I just want to go ahead and do this for the next one also, just to make sure that you guys understand how to write these expressions. So we have concentration of H2, and then this is squared. So what I'm doing is the number that are in front on your reaction, they get pulled up as an exponent in the equilibrium expression. BR2 over and this is over HBr squared. And that value there, it's a 10 to the minus 18. That's a very small number. That is definitely less than 1. So this one is telling you that reactants dominate. Oops, I was using just this. All right, so there we go. Did you guys have any other questions while we're on here? Any other questions? Switch over to face. All right, so yeah, so if you guys don't have any other questions, I think we're actually at a good point to cut the stream. So I am actually going to be writing the exam here in probably the next few days. It'll be available on Canvas, so just make sure that you guys have already done the quizzes first. You want to do the homework first, talk to each other, study. I also want to mention that my students are using an app called Zoom to talk to each other. You can do that instead of Discord. Zoom is basically an app where you can basically do set up conferences, and you have like video feeds of each other talking, and you can like show your notes and all that you're writing, and you're kind of like working together, but you're all at home. You can also do that in Discord too. If you don't like Discord, you can use Zoom, whatever you guys want to do. The exam I'm going to try to have it ready before Wednesday. I had a few ideas of things I was going to do that I need to figure out how to do. So we'll hope that everything is ready by then. For sure, I'm going to have it before spring break. It'll be done like before spring break. I definitely wanted that due. So yeah, so at the latest Thursday. So definitely plan on the latter part of this week getting it done. The due date is going to be like the same time as the other quizzes. So you definitely want to do the other quizzes first, but do the exam after, and it'll be before Sunday, before spring break officially starts. All right, guys. I'm going to go ahead and cut the stream right here. Unless you guys have any other questions that you want to ask real quick before I cut this, and I'll hang on the Discord chat for a little bit longer if you wanted to ask anything in the chat. All right, just wait a second. All right. That's a little handsome. All right, guys. Let's just go ahead and cut it here. Stay safe, everybody. Happy studying. Remember, you guys are always more than welcome to ask me questions, either in the Discord, or you can go ahead and message me on Canvas or email. I'm trying to be responsive to everything. I'm kind of just sitting at my desk anyway all week. All right, guys. Have a good one.